Okay, hello and welcome back. My name is Amir and we are continuing our journey into the Codewars website, going to 1K. We are currently at 5. Okay, I have selected difficulty of 5 and let's see what we are facing for today. So this is called trees to parentheses and back. Okay, let's go and see. The binary trees can be encoded as strings of balanced parentheses. Okay. In fact, the two things are isomorphic. Your task is to figure out such an encoding and write the two functions which will convert back and forth between the binary tree and the strings of parentheses. So here's the definition of binary tree. So we have these, and there are the functions you need to define. These functions, tree to parents, which would take a tree and the number of leaves and branches it has and convert it to a string of parentheses, something like this. And then another function, parents to tree, which will take a string, something like this, and returns a tree representation of that string. The first function needs to return only strings of valid balanced parentheses like this, and I believe this is the input is always a valid balanced parentheses. The second needs to accept any string of balanced parentheses. Okay, also the function needs to be inverses of each other. So if we say tree to parents of parents to tree of parents, it should be the parents, and the vice versa here. So note there is more than one possible answer to this puzzle. There are a number of different ways to encode a tree as a string of parentheses. Any solution that follows the law, it will be accepted. Your functions will run in sandboxes. So only tree, leaf, and branch and console for.log will be in scope, and they will be frozen. Okay, so you cannot change any of these. If you need helper functions, define them inside your function. Okay, if you experience any problems with this setup, please leave a comment in the discourse. Okay, so this is a good time to pause the video and try to solve it by yourself. Otherwise, we can jump right into it. Okay, let's go here. I will grab these, go to my code editor, and what did we have? We had tree, leaf, and branch. So a tree is just an empty object. Leaf is also an empty object which extends the tree, and the branch also extends the tree, but it will get a left and a right. Let me copy and paste these as well here. Okay. So when we get a tree, it will probably be empty, or it will have a branch to the left and to the right. If it's an empty, then we would return a empty string and we are fine. Otherwise, if it is a branch, then it will have a left and a right. And any of the left and the right can also be a branch or a leaf, right? So let me give you an example here. Let's say binary tree and see what we get here. I think any of these will do. So let's go here. So this is a tree. When we are here, we would have a branch. This is a branch. We would go to the left or to the right. When we go to the left, then there is a branch also to here, and so forth and so on. And when we get here, this is a leaf. It doesn't have any branch. So when we are like traversing from here to parentheses, we would get this, and then go to the left and go to the right, and then parse this. So let's go to the code and see. So I would say that if tree is instance of a leaf that we have here. So if a tree is a leaf, then just return an empty string, and then we are fine. Otherwise, now this is the important part. We need to return a parenthesis, and inside this parenthesis we would go to the left and go to the right. So I would have a string literal here of 3 to parens of our left, so 3 dot left, and this should be like this. So I would have this and 3 to parens of right. Great. And then the other one, which we are converting the parentheses to a tree. So let's go here and say we have something like this. In this case, we are going from like a left parenthesis or an open parenthesis to the right. When we are here, we would know that this is going to be a branch. Yes. And it will have something inside. So for example, here we have a branch with left and right. But here we have a branch that will have another branch and so forth and so on. So we would start from here and go forwards. If we get to a open parenthesis, we would say this is a branch and then do the recursion on that branch. Otherwise, it is not a branch. It is just a leaf, something like here, right? Or for example, when we are here, we would say, okay, this is a branch. Give me a tree based on that. And when we get to this one, this is not a new parenthesis. This is not a new branch. So we would say this is a leaf. So we would get a tree. Okay, so let's write it in code. It might get more clear. So here, as I'm starting from the left to right, I would have a counter starting at 0. And then we would do a recursion. So we would define a recursion function here. I would call it recursion. And this would take a look at the parentheses at index I. So if the parenthesis at index I is a open parenthesis, then it would be a new branch of the recursion of I plus 1. Sorry, I plus plus, so that we go 1 ahead. And then another recursion for the right. Again, I plus plus. So you can see that branch would take 2 arguments left and right, and if we get to this, we would get a new branch, the next character and the next character after that. Otherwise, it would be just a new leaf. And then I need to just run the recursion and return the value. And I'm passing the I++ here to do it in one go. Otherwise, I could have a curly brackets, add I, and then do the new branch, and then go here. But this is going to do it in just one go. So this looks correct to me. Let me grab this code here and paste it here and see what we get. Awesome. So this was about it for this puzzle. Thank you for watching, and see you in the next video.